2002 version of Chapter 14 no longer explicitly addresses the number of conductors allowed per terminal connection. However, it is generally accepted that the requirements of the previous edition still apply unless specifically amended. NFPA 70 2017 edition, Section 110.14b states conductors shall be terminated only in listed terminals. Section 408.20 addresses terminations for listed non-metallic enclosures. The power distribution blocks used must be listed for use with the number of conductors being terminated. The wires connected to each terminal must be of sufficient ampacity for the load they will be supplying. The conductors must be securely terminated in the terminals according to the manufacturer's instructions. Based on this analysis, it is acceptable practice to put two wires into a single hole or pole connecting point on a power distribution block, provided the distribution block is listed for use with two conductors per terminal. Also provided the wires are of sufficient ampacity for the load and the conductors are securely terminated according to the manufacturer's instructions. Firstly, consider listed terminals. The power distribution block must be specifically listed and labeled for use with two conductors per terminal. This listing ensures the terminal is designed to safely accommodate multiple conductors and maintain a secure connection. Consult the manufacturer's specifications and any relevant certifications to verify the terminal block suitability. Secondly, address ampacity requirements. Each wire connected to the terminal must have sufficient ampacity to carry the load it is intended to supply. This means the wire gauge must be appropriately sized to handle the anticipated current without overheating. Conduct a thorough ampacity calculation taking into account factors such as ambient temperature, conductor insulation type, and any directing factors that may apply. Thirdly, ensure proper termination. The conductors must be securely terminated in the terminals according to the manufacturer's instructions. This typically involves tightening screws or clamps to the specified torque to ensure a reliable electrical connection and prevent loosening over time. Use appropriate tools and techniques to avoid damaging the wires or the terminal block. Also consider the additional considerations for optimal wiring practices. It is good practice to leave some slack in the wires after they are terminated to allow for movement and prevent strain on the connections. This slack can help prevent the wires from being pulled out of the terminals due to vibration or other external forces. If the wires are large or stiff, it may be difficult to insert the second wire into the terminal. In such cases, it is best to use a terminal block with larger holes or multiple termination points per pole. Using a suitable terminal block can make the wiring process easier and ensure a more secure connection. Also note that the above interpretation only applies to 600 volts or less power distribution blocks. Terminals for higher voltages may have different requirements. Consult the relevant standards and regulations for specific guidance on high voltage applications. When dealing with electrical wiring and terminations, safety should always be the top priority. Ensure that all work is performed by qualified and experienced personnel who are familiar with applicable codes and regulations. Always to energize the circuit before working on any electrical connections and use appropriate personal protective equipment (PPE) such as gloves and eye protection. Now consider additional details about ampacity and temperature. The ampacity of a conductor is the maximum amount of current, measured in amps, that it can carry continuously without exceeding its temperature rating. Several factors can influence a conductor's ampacity, including its size, material, insulation type, and the ambient temperature in which it is installed. The National Electrical Code, or NEC, provides tables and guidelines for determining the appropriate ampacity for different types of conductors and various installation conditions. When terminating two conductors in a single terminal, it is crucial to ensure that the terminal is rated for the combined ampacity of both conductors. If the terminal is not rated for the total current, it could overheat and potentially cause a fire. Therefore, always consult the manufacturer's specifications for the terminal block to determine its maximum current rating. Temperature is a critical factor in determining the ampacity of a conductor. As the temperature of a conductor increases, its resistance also increases, which can lead to further heating and potentially damage the insulation. The NEC specifies temperature ratings for different types of conductors, indicating the maximum temperature at which the conductor can safely operate. When selecting conductors for a specific application, it is essential to choose conductors with a temperature rating that is appropriate for the ambient temperature and the anticipated load current. If the ambient temperature is high, it may be necessary to use conductors with a higher temperature rating or to direct the ampacity of the conductors to prevent overheating. Directing factors are used to reduce the ampacity of conductors when they are installed in conditions that can increase their temperature, such as when they are bundled together or installed in raceways. The NEC provides tables and guidelines for determining the appropriate directing factors for different installation conditions. Another important consideration is the type of insulation used in the conductors. Different insulation materials have different temperature ratings and resistance to heat. The NEC specifies the types of insulation that are permitted for different applications and provides guidelines for selecting the appropriate insulation for the specific conditions. In addition to the ampacity of the conductors, it is also essential to consider the ampacity of the overcurrent protection device, such as a circuit breaker or fuse. The overcurrent protection device is designed to protect the conductors from overload and short-circuit conditions. The ampacity of the overcurrent protection device should be sized to protect the conductors without causing nuisance tripping. The NEC provides guidelines for selecting the appropriate overcurrent protection device for different types of circuits and conductors. It is also important to ensure that the conductors are properly terminated in the terminal block. Poorly terminated conductors can create high resistance connection, which can lead to overheating and potentially cause a fire. The conductors should be securely tightened in the terminal block using the appropriate tools and techniques. The terminal block should also be inspected regularly to ensure that the connections are still tight and that there are no signs of corrosion or damage. Finally, it is essential to follow all applicable codes and regulations when installing and terminating conductors. The NEC provides detailed guidelines for electrical installations, and it is important to be familiar with these guidelines to ensure that the installation is safe and compliant. Local codes and regulations may also apply, and it is important to check with the local authorities to ensure that the installation meets all requirements. Now to explore terminal block types and selection. Terminal blocks are essential components in electrical systems, providing a convenient and organized way to connect and terminate wires. They come in a wide variety of types and sizes to accommodate different wiring needs and applications. Selecting the right terminal block for a specific application is crucial to ensure a safe and reliable electrical connection. One of the most common types of terminal blocks is the screw terminal block. These terminal blocks use screws to clamp the wires in place, providing a secure and reliable connection. Screw terminal blocks are available in a wide range of sizes and configurations to accommodate different wire gauges and numbers of connections. They are also relatively inexpensive and easy to use, making them a popular choice for many applications. Another type of terminal block is the spring clamp terminal block. These terminal blocks use spring-loaded clamps to hold the wires in place, providing a vibration-resistant connection. Spring clamp terminal blocks are particularly well suited for applications where vibration is a concern, such as in industrial machinery or transportation equipment. They are also faster and easier to install than screw terminal blocks, as no special tools are required. Barrier terminal blocks are another common type of terminal block. These terminal blocks have a physical barrier between each terminal, providing insulation and preventing short circuits. Barrier terminal blocks are often used in high-voltage applications or where there is a risk of accidental contact with live wires. They are also available in a variety of sizes and configurations to accommodate different wiring needs. Feed-through terminal blocks are designed to allow wires to pass through the terminal block without being terminated. These terminal blocks are often used to connect wires between different panels or enclosures. They are available in a variety of sizes and configurations to accommodate different wire gauges and numbers of connections. Ground terminal blocks are used to connect ground wires to a common ground point. These terminal blocks are typically green or green with a yellow stripe to indicate the grounding function. Ground terminal blocks are essential for ensuring electrical safety and preventing equipment damage. In addition to these common types of terminal blocks, there are also a variety of specialty terminal blocks available for specific applications. These include fuse terminal blocks, which incorporate a fuse into the terminal block for overcurrent protection, and disconnect terminal blocks, which allow for easy disconnection of wires for maintenance or troubleshooting. When selecting a terminal block, it is important to consider several factors, including the wire gauge, the number of connections required, the voltage and current rating, and the environmental conditions. The terminal block should be sized appropriately for the wire gauge to ensure secure and reliable connection. The number of connections required will depend on the specific application. The voltage and current rating should be high enough to handle the anticipated load without overheating. The environmental conditions, such as temperature, humidity, and vibration, should also be considered when selecting a terminal block. Now let's discuss NEC regulations regarding terminal blocks. The National Electrical Code, or NEC, provides specific requirements for the installation and use of terminal blocks in electrical systems. These requirements are designed to ensure electrical safety and prevent fire hazards. One of the most important NEC requirements for terminal blocks is that they must be listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL. Listing indicates that the terminal block has been tested and meets certain safety standards. The NEC also requires that terminal blocks be used within their listed voltage and current ratings. Overloading a terminal block can cause it to overheat and potentially start a fire. The NEC also specifies the types of conductors that are permitted to be used with terminal blocks. In general, only copper or copper-clad aluminum conductors are permitted. Aluminum conductors are not permitted to be used with terminal blocks unless the terminal block is specifically listed for use with aluminum conductors. The NEC also requires that conductors be properly terminated in the terminal block. This means that the conductors must be securely tightened in the terminal block using the appropriate tools and techniques. Loose or improperly terminated conductors can create a high-resistance connection, which can lead to overheating and potentially cause a fire. The NEC also specifies the minimum spacing requirements for terminal blocks. This spacing is designed to prevent short circuits and arcing between terminals. The spacing requirements will vary depending on the voltage and current rating of the terminal block. The NEC also requires that terminal blocks be protected from physical damage. This can be accomplished by installing the terminal blocks in a suitable enclosure or by providing other forms of protection. The NEC also requires that terminal blocks be properly identified. This means that the terminal blocks must be labeled with their voltage and current rating, as well as any other relevant information. Proper identification is essential for ensuring that the terminal blocks are used safely and correctly. In addition to these general requirements, the NEC also provides specific requirements for terminal blocks used in certain applications, such as in hazardous locations or in healthcare facilities. It is important to be familiar with these specific requirements if you are installing or using terminal blocks in these types of applications. Now we will cover best practices for wiring terminal blocks. Wiring terminal blocks correctly is essential for ensuring a safe and reliable electrical connection. Following these best practices can help prevent common wiring problems and ensure that the terminal blocks function properly. Firstly, select the right terminal block for the application. As discussed earlier, it is important to consider several factors when selecting a terminal block, including the wire gauge, the number of connections required, the voltage and current rating, and the environmental conditions. Choose a terminal block that is specifically designed for the intended application and that meets all applicable codes and regulations. Secondly, prepare the wires properly. Before inserting the wires into the terminal block, strip the insulation to the correct length. Use a wire stripper to avoid damaging the conductors. Twist the exposed conductors together to create a solid connection. Thirdly, insert the wires correctly. Insert the wires into the terminal block until they are fully seated. Make sure that the wires are not frayed or damaged. Tighten the screws or clamps to the specified torque. Over-tightening can damage the terminal block or the wires, while under-tightening can result in a loose connection. Fourthly, label the wires clearly. Use wire markers or labels to identify each wire. This will make it easier to troubleshoot problems and make changes to the wiring in the future. Fifthly, organize the wires neatly. Use cable ties or other means to bundle the wires together and keep them organized. This will make the wiring system easier to maintain and troubleshoot. Sixthly, inspect the wiring regularly. Periodically inspect the terminal blocks and wiring for signs of damage or corrosion. Tighten any loose connections and replace any damaged components. Seventhly, follow the manufacturer's instructions. Always follow the manufacturer's instructions when installing and wiring terminal blocks. This will help ensure that the terminal blocks are installed correctly and function properly. In addition to these best practices, there are also some common wiring mistakes to avoid. These include using the wrong size wire, over-tightening or under-tightening the screws or clamps, and failing to label the wires clearly. Avoiding these mistakes can help ensure a safe and reliable electrical connection. Now let's discuss troubleshooting terminal block connections. Even with proper installation and wiring, terminal block connections can sometimes fail. Troubleshooting these connections effectively can help identify and resolve problems quickly, minimizing downtime and ensuring electrical safety. One of the most common problems with terminal block connections is loose connections. Loose connections can be caused by vibration, temperature changes, or improper installation. They can result in a high-resistance connection, which can lead to overheating and potentially cause a fire. To troubleshoot loose connections, visually inspect the terminal block and wiring for signs of damage or corrosion. Tighten any loose screws or clamps to the specified torque. If the connection is still loose, the terminal block may need to be replaced. Another common problem is corroded connections. Corrosion can occur when the terminal block is exposed to moisture or other corrosive elements. Corrosion can also result in a high-resistance connection and potentially cause a fire. To troubleshoot corroded connections, clean the terminal block and wiring with a wire brush or other abrasive material. Apply a corrosion inhibitor to prevent future corrosion. If the corrosion is severe, the terminal block may need to be replaced. Overheating is another potential problem with terminal block connections. Overheating can be caused by overloading the terminal block, loose connections, or corroded connections. Overheating can damage the terminal block and wiring and potentially cause a fire. To troubleshoot overheating, check the load on the terminal block to ensure that it is within the rated capacity. Inspect the terminal block and wiring for signs of damage or corrosion. Tighten any loose connections and replace any damaged components. If the terminal block continues to overheat, it may need to be replaced. Short circuits can also occur in terminal block connections. Short circuits can be caused by damaged insulation, loose wires, or foreign objects. Short circuits can damage the terminal block and wiring and potentially cause a fire. To troubleshoot short circuits, visually inspect the terminal block and wiring for signs of damage or loose wires. Use a multimeter to check for continuity between the terminals. If a short circuit is detected, isolate the cause of the short and repair or replace the damaged component. Open circuits can also occur in terminal block connections. Open circuits can be caused by broken wires, loose connections, or corroded connections. Open circuits can prevent current from flowing through the circuit, causing equipment to malfunction. To troubleshoot open circuits, visually inspect the terminal block and wiring for signs of damage or loose wires. Use a multimeter to check for continuity through the circuit. If an open circuit is detected, locate the cause of the open and repair or replace the damaged components. When troubleshooting terminal block connections, it is important to follow proper safety procedures. Always to energize the circuit before working on the terminal block. Use appropriate personal protective equipment, such as gloves and eye protection. If you are not comfortable working on electrical equipment, consult a qualified electrician.